Okay, something went wrong with my camera. It kind of semi blew up. So I'm just going to leave it off. I'll still share the screen is shared. That's good. So you won't get to look at me as I soothe you to sleep here. But you can still look at this lovely presentation. Now, the reason this is kind of a new topic in the course. Adrian DeWitt, what? Hold on a second. I think Adrian's on the wrong channel. I'm not sure. I think he went to the wrong place. Yeah, I think he did. Unless I'm in the wrong place, but no, that means you guys are too. Whoops. Yeah, okay. Oh, well, he'll be along here. Oh, there he is. Hi. That's all good. He'll find his way. Wrong place, right time. I've actually lectured wrong place, right time. So I'm like, why is nobody here? Oh, well. Okay, I'm just going to try my camera again. Yeah, there we go. I don't know why it blew up. Okay. So, um, what I want to do is I've changed the secure apps assessment because it was a little too hard, I felt. People were a little too frustrated. I kind of threw them into the deep end thinking, they're fourth term, they can handle it. But there was much wailing and gnashing of teeth. So I've kind of, it's still a bit of a challenge, but it's a bit more focused, and I'll prepare you a little bit more for it. Okay. So in the previous one, I would give you like six different scenarios or nine different scenarios. I think it was nine different kind of circumstances where you could apply um, certificates, and then you just get to choose, three or four of them. Anything that added up to 10, you know, in terms of marks and stuff. So that seemed to kind of drive people a little bit crazy because they would find the easy ones manageable, and then everything else was too hard. So what I'm going to do instead is I'm going to give you a fixed assessment using a web server, HTTPS, and FTPS. Okay, and you have to configure certificates, but I'm going to add a wrinkle, which is that your client, although it can be domain joined and should be domain joined, I want you to access it from the outside world, so VMnet 8, which means you're going to have to punch a hole through the firewall, and you're like, oh, it doesn't sound that bad. And it's not terrible, but it's a little more complicated than you think. Okay. So I'm not releasing the lab yet, but I am going to do a lecture here, and I'm also going to give you an extra exercise just to make sure that you're kind of comfortable. And I feel normally this, if you look at the slide, this is like mail server, right? What I did, I just co-opted one of the mail server lectures, which is a little dense for lectures, and I just kind of adjusted it for network address translation because this will be useful in, it's a bit of a guide to PFSense. It helps you set it up. This will be useful in Capstone. It's going to be useful in Mail Server, but this is the first class where you're actually going to have to work with it a little bit. So that's what I want to do. So I'm going to do this lecture, and then I'll set you loose on the exercise. I haven't finished setting up this assessment yet. There's a couple things I got to do. So I'll release that, I don't know, sometime next week, probably. Okay. And I'll give you, the same amount of time that you had before. You might not need that much, but we'll leave it as it is. Okay, any questions before I go on? I have a bit of an allergy reaction to my cat right now, so if I'm a little sniffly, please forgive me, or forgive the cat, as I did. Okay. Okay, so NAT firewalls. NAT stands for Network Address Translation. And so there are different firewalls out there. Not all of them are NAT based. Okay. Um, but Most of them are NAT based these days. Okay. So NAT introduces some complications into networking in general. It also provides a lot of benefit. So the hassle that you have to deal with is insignificant compared to the benefits that it provides. So we'll go into that. Doo, doo, doo. Okay, so I'm just going to talk about general firewall concepts very briefly, and then we're going to get into PFSense and some of its features, how you can implement your own PFSense firewall router. So this might be useful for Capstone. It's definitely going to be useful for 2512. And excuse me, it'll be you're gonna basically I'm going to allow you to repurpose the current router that we have. Um, for this class. So you're not going to have to rebuild it, but you can use it to set some rules. Okay. And then testing and troubleshooting your setup. That's going to be a big part of your assignment, essentially. Okay, so in general, firewalls restrict access to networks. There's different levels of firewalls. So packet filtering, this is kind of review from, I don't know, 2518 or I don't know, 20, what is it? 1518 or 1014, you know? But there are different types. There's pure packet filtering. The only thing it does is examine the headers of packets. Okay, and it makes decisions based on rules that you set up about the nature of those packet headers. So if the packet's identified as going to a certain port, you can allow it or block it. If it's using TCP or UDP, you can also establish rules along those lines, ping, things like that. But it's all about examining the packet headers, right? Now, the reason that we do this, we don't look at the data because looking at the data is much more computationally intensive. So if you're just looking at the headers of the packets, then you can process everything very quickly. So these are very fast firewalls, and they don't have to be very powerful. Okay? Um, but they're also limited. So fast but limited. Okay. Now, over time, people added features to packet filtering. They introduced something called stateful filtering. So they added a little bit of extra hardware to give the devices a little more oomph, you know, and then they would be able to not only look at the packet headers, but also interpret whether a session was being established, like a TCP session, right? So if a TCP session was being established, it would actually track that and it would allow those packets through going forward. Okay. So this was much more flexible. It did require a little bit more hardware, and that's where we're typically at with a home router, let's say. Okay. So if you get like a cheaper device, even the ones that are a bit expensive, like a couple $100 or whatever, they're just doing stateful filtering. And this is usually more than enough. Okay. And that's really where we're going to focus on with PFSense. That's what it can do more, but we're not going to ask it to. Okay. The next layer up after that is application layer firewalls. That's kind of the big daddies of firewalls. So these are enterprise expensive firewalls. You're paying some fancy company big bucks for these kind of things. So it's the same as all of these. It's got all of these features, okay? But it also inspects the packets at the data level, so the payload, right? And it understands the protocols that are being used. So it's not just saying, oh, it's a DNS packet. It's like it understands the DNS protocol, the queries that are supposed to be there. So, you know, whatever the application layer firewall, you might only have it for web, let's say, okay? You may not have it so that it's working and inspecting DNS. It depends what you pay for, really. But you can get ones for DNS, mail, HTTP, et cetera, et cetera. Okay. This is much more robust protection. What it can do then is it can actually look for attacks that might be occurring. So, say a web server, somebody's trying to hack into it. By inspecting the packets, it can apply kind of antivirus, anti-malware um, filtering capabilities at the firewall level, right? Now, if you think of that, that sounds like a slow process, right? And so you need a beefy server to actually do this kind of work, okay? And even if it's beefy, it's going to slow down the whole process in general. However, it provides you with a much greater level of security. Okay. So a lot of organizations, if they're big enough, like NAT or a large corporation, they will have application layer firewalls, or they'll have firewalls that are capable of packet inspection at the payload level. Okay. So what they can do then, not just detecting malware, but they can look for unusual patterns of all sorts, right? So if you're loading, um, let's say you're trying to exfiltrate data, right, which is just uh, push data out of the environment in a way that is less noticeable. Okay, so let's talk about, I don't know, Russian hackers who want to, they've managed to get into an environment and they want to get their data out, but they don't want to be noticed. They might push things through, an SSL connection, or they might do it more creatively, like say through a kind of a rigged ping connection. Okay. Uh, a, a deep packet inspection application layer firewall will be able to look at those packets and say, this isn't the normal data that I would expect from a ping. Or why is there a packet, why is there a whole bunch of SSL going to this IP address which I haven't logged before? You know? In other words, like we don't usually do business with it. So that's really, we're not going to deal with that, but that is out there. And I wouldn't expect you necessarily have to deal with it, but you might. It depends on the environment. Okay. And if networking becomes your thing, you might kind of gravitate in that direction. Okay, so the thing that I really want to focus on is network address translation. You've probably worked with it a little bit before, so it's an important feature of firewalls these days. Ever since we've started running out of addresses, right? And the idea is in IPv4, when we did start running out of addresses, we would hide entire networks behind a single public IP address. And so those networks are using internal IP addresses, which aren't supposed to route on the internet. Okay. So if a router gets an IP address like that, it's going to be like, no, you're not meant to exist on the internet. The whole purpose of NAT is for that one IP address that's public facing to carry out all of the requests for all of the clients on the inside by rewriting the packets so that they seem to come from that IP address instead of the ones behind it. Okay. And that's because that IP address is acceptable for routing on the internet. The benefit of this is that you know, the dearth of IP addresses, public IP addresses, is no longer a crisis, right? Um, Even now, like we've technically run out of IP addresses, but the internet's not crashing. Like we're doing okay, you know. And that's actually slowly reversing now as people are starting to move to IPv6. We're starting to have more addresses available. So NAT kind of saved our butts in that way. Um, Now, a firewall that performs this function has to act as a router because it's got to have two IP addresses, one on the outside with a public facing and one on the inside so that it can talk to all those clients, right? Other firewalls could just have strictly public IP addresses or strictly private ones. But if you're dealing with NAT, you're dealing with two networks, and typically one of them is external. Okay. So the outside world only sees the firewall router, and it thinks all the requests are coming from it. All right. Now that does introduce a few complications. But in reality, the NAT firewall is receiving internal packets and it's doing the work of rewriting the IP headers. It has to do that pretty fast to insert itself as the source address. So it's swapping out the source address and faking it, tracking who the original source was, and restoring that source address when it receives a reply. So this is actually a typical man in the middle kind of situation, but it's not an attack. Okay, it's actually helping things to function. It's a bit closer to a proxy, except for all TCP/IP packets. Okay, now in terms of ports, and this is something you're going to have to massage and work with a bit, the default behavior of a firewall is to block all the incoming ports. Okay, It used to be firewalls would be released, and some of them were configured that the default behavior was to allow everything, and then you had to tighten it up. That's not good practice. So that doesn't happen anymore. So now all of them come restricted, and then you got to loosen it up. You have to know enough about it to loosen up the appropriate ports. Okay, and if you think, oh, that sounds pretty easy, it can get complicated, and FTP will be one example of that. Okay. If we want to allow traffic to flow between two networks, we need to unblock some of those ports. And generally, we only unblock the ports that we need to use. But the question is, what do we need to use? And the answer is that depends on the protocol. Okay. So with web servers, there's HTTP, which is port 80. There's HTTPS, which is port 443. And then there's FTP, which is complicated. Okay. So FTP originally used two ports, 20 and 21, and you typically only had to open up one of them as a server. Excuse me. But over time, um, the how do I put this? The availability of free firewalls and their use amongst client systems kind of complicated the process, and they had to change the protocol so that dynamic ranges were used. So dynamic ranges are the ones that are higher up, the higher up numbers. And typically firewalls don't block those ports, but if they do, you're going to have problems with FTP. Okay. So basically, FTP takes a little bit of tweaking, trial and error, which you're going to see when you're actually doing the Secure Apps Lab. Okay. But you do need one of these ports open, and you're going to have some dynamic ranges, and you're going to have to establish some rules about that. So in a NAT configuration, beyond opening the ports, you also have to configure forwarding, right? So a typical firewall, you're just opening up ports. With NAT, you're not just opening up a port. You're saying anything that's coming in on this port, I want it to be rewritten so that it goes to this server on the inside. Okay? Um, and so that's again where testing has to come in. And when you're setting up a NAT router and you're trying to test, whether a client can get in to talk to the server, there's two parts to that. There's getting the message to the server and getting the reply back, right? And it can be a little hard to tell which one is failing. So you have to read your rules carefully, make sure that you understand what's supposed to happen. Okay. So in the case of web servers, you might have an internal web server that needs to allow connections from the outside. In this case, we'd map incoming port 80 on the router's IP address, the public one, to port 80 on the internal mail server. Okay, and that means that anything that router gets on port 80 is going to go to that guy. Okay, same thing with 443. If you want to have HTTPS, you want to redirect that to the internal, not mail server, sorry, the web server. It's less common these days, as you know. By default, we're using HTTPS a lot. Ever since we found out that the American government spies on everybody, right? So, so since then, we don't really use 80, but at the firewall level, we do leave it open. We let the web server decide. Um, whether to forward that port 80 request onto 443. So it's usually an HTTP server kind of configuration, which receives a request on port 80, gives back a port 80 reply, but it's a redirection to say, yeah, switch over to this protocol. Okay. So it's not usually at the firewall level, we do usually allow it through because a lot of people don't, especially if they're older, they don't really know that HTTPS is the default nowadays. Okay, so they don't want them to go to port 80 and then just find that it's closed and they can't visit the site. So they allow it in and then push them up to 443. Let's see. So let's get into PFSense here. This is an open source firewall based on FreeBSD. It's actually not Linux. It's a variant of the BSD flavor of Unix operating systems. That's older than Linux essentially. Not Linux, yeah. but very similar. So don't get too excited there. But this is like a very focused, a focused OS. So its job is just to do firewalls. Uh-oh. You'll be fine. You're gonna love it by the end of this. So it has a good reputation. It's got quite robust capabilities, given that it's built out of FreeBSD. Like they've added a lot of good features to it. And it also has the benefit of being able to run using very low hardware resources. And so that's why I chose this. I could install it on an x86 operating system, so it could go into VMware, right? Or an x64. And it didn't take a lot of resources, so I didn't need like 2 or 4 gigs of RAM to run it. I can run it off of 500 megs. So it kind of gets out of the way. In terms of the space it takes up on your disk, it's also like a gig, you know. So it's really quite a nice little option, and that's kind of why I use it. But it gets a lot of respect out in the real world as well. What you will find is that large enterprises may be less likely to use it. Um, like the really big guys, like say PCL or NAT or something like that. And there could be different reasons for that. You might find it in smaller like fewer instances of it in those environments, but often they're paying big bucks to go with like a Cisco firewall or, you know, I think Aruba is Cisco these days, but different ones that are an HP firewall. They'll pay one of those vendors an arm and a leg, and then they'll pay for support, you know. This is kind of our poor man's version, but it's actually a fairly nice poor man's version. The main interface, and you've worked with it a little bit, the main interface is a simple menu, right? So not much to that. You do the basic configuration with that, and then that gives you access to a web interface. The web interface is where you can do the real kind of heavy configuration. Now, it is possible if you're well experienced to use a standard Unix shell to directly configure the system. I don't recommend this for any of you guys. I wouldn't bother to do it myself, to be honest. Although I do sometimes edit the odd thing here and there. Usually it's because I'm hacking the system, not because I'm trying to configure it, like I'm trying to do something extra, not something that they envisioned. So most of the time you want to work with this menu, right? Now, this one is an example from 2023. So this was the gateway that I gave you back in that class, if you took that class with me, which I think you all did. So, because no one else is teaching it for the last little while. But basically, here there's 4 NICs with 5 IP addresses on it. Okay, and this is how the menu looks. Fairly simple properties, right? Now, the LAN interface, if we go back there, that would be this one, right? That's the default internal LAN. Okay, the WAN interface is your external facing address. Now you'll notice that we're not using an external address on the WAN interface, and that's just something in our program. Um, a lot of the time, if you're using a PFSense firewall, this is going to have like an IP from your ISP, right? Now the opt interfaces, those are additional network interfaces. If you have other networks that you need to connect into this PFSense router, then you can just add other NICs if you like. You could also do subnetting where everything's on one NIC and it's just virtual addresses. That's a little bit more advanced, but you can do it. Now, option 2 in the menu can be used to enable DHCP. So you can host DHCP or you could choose not to. Um, so, oh, sorry, this is whether you're acting as a DHCP client. So on the WAN interface, you could statically set the IP address, or you could use DHCP to pick it up. Okay. So in the example image there, we can see the LAN interface has been configured to use DHCP. Sorry, that's the WAN interface, while the LAN interface has static internal and IPv6 addresses. Okay, so these are hard-coded. This one is picked up from VMnet 2. Okay. So the main menu is used to initialize the system. Then you got the web interface. The web interface can only be accessed on the LAN interface by default. You have to configure it to allow for anything else. Okay. Oh, hold on one second. I'm just gonna mute myself. I gotta. Okay, slight home emergency, not a big deal, but I'm gonna take 5 minutes. Okay. I just need to help with a bit of a problem. I'll BRB. The imposter is there. No, the garage door wouldn't open, so it seems like it broke or something. Anyways, I got it open, but I had to be a little creative. So we're all good. Let's see. Now, where was I? Okay, yeah. So you need a web browser on the internal LAN in order to access the web interface. The default username and password, just for um, your knowledge, is admin/pfsense. So admin is the user, pfsense is the password. Okay. Now, if we go back and we look at the menu, option 3 lets you reset the web configurator password. And so for this exercise, you can just, I actually don't remember the password I set on this system. I can probably figure it out, but just reset the web configurator password, and then you'll be able to log into the system, um, and then do your own configurations. Okay. Another useful menu option is 4, which resets the whole system back to default settings. So if you've totally screwed up the system to the point that you can't access the web interface, you can't really do anything with it, you can at least go to the menu and you can reset to default, and then everything will be available, even if you lost your settings. Okay. So here's an example. And again, I'm just using the one from 2023 because, you know, you're not going to be working with that anymore, but it still gives you an example you're familiar with. So admin, pfSense, sign in, and this is what it's going to look like. Okay, so it's saying where I'm connecting from. You know, they're trying to get you to buy some support, and some basic settings, what release you're on, stuff like that. We don't spend a lot of time at the dashboard for the most part, really. Most of our time is going to be spent up in the firewall section, okay, or the interfaces section, sometimes under system. So here, if we go to Firewall, Rules, LAN, we can inspect the rules that are already there. Okay. And all this is doing, there's an anti-lockout rule, which is allowing connections on port 80 to the LAN address of this router. Notice it's not giving a particular address, which is kind of nice because if we had the wrong value there, we'd be locked out. But this is so generic, it's just saying 80 is allowed to come to the LAN interface, whatever its IP address is. Okay. So if you make any other dumb rules, this one should still allow you to get back in. If you move this down in priority and you insert a block rule, that might actually ruin the whole thing for you. So you can move rules down by just kind of dragging them up and down and through the interface. Okay. The highest rule is the first one that's going to take effect, and then anything else doesn't get processed typically. Okay. Now, the other rules here are very, very loose in the LAN. They're just saying if you got an IPv4 packet, so that is to say pretty much anything except ping, no, even ping, it's like allow it, right? And then the same thing with IPv6. So anything goes in the LAN, basically. Okay. Let's see. So any traffic coming into the LAN from another interface is blocked by that interface. So LAN is not doing any blocking, but WAN, Opt1, and Opt2, they're not letting anything through. Okay, and so if I'm trying to come in through WAN to get to LAN, the WAN rules are going to say, okay, and same thing with Opt1 and Opt2. There's actually no rules configured here by default, but the default behavior is to block. And so unless I open something up, nothing's getting in. Okay. So more rules need to be configured to allow access. The higher up the rule, the higher its priority if there's a conflict between two rules. Okay, so you can kind of move them around just to massage that priority. Now, let's say we want to add a rule to allow hosts on the Opt2 network to access the web management interface. So I'll go back here again. No, that's that. No. Yeah, I want this. Okay. So let's say I have a host on Opt2. Now, there's no rules in Opt2, and that means that it's not really allowing anything to get out or in. Okay. If I want a host on Opt2 to be able to visit the LAN interface, then I need to make a rule on Opt2 that's allowing it to do that. Okay. LAN itself is okay. It's allowing all sorts of stuff. So I don't need to configure LAN, but I do need to configure Opt2. So what we need to do is the LAN interface is statically set to 99.9 in this particular case. Okay, so we need to allow Opt2 traffic to that interface to access port 80. Okay, so we have no SSL installed on this right now. Now the LAN interface has that broad rule, so we're not worried about that. We'll add a very specific rule in Opt2 just to show how you can actually allow that through. And you've got to look at balancing security and functionality when you're creating these rules. Some firewall admins, they get a little enthusiastic, you know. You can see that with lots of like security people. They get a little bit gung ho, and they forget that if people can't do their jobs because of your rules, like it might be secure, but it's not usable, right? So you really do, you have to think, is this going to make everybody's life hell? Or it's kind of like password policy, is this going to make everybody's work hell? And are they going to try and bypass it because of that? In order to get security to work, you have to get buy-in from people, So you got to think of usability. So requirements always depend on the use case, but there's that balance you've got to hit. Okay. So if we go over to firewall rules and we click on the Opt2 section here, you're going to see that there are no rules. We go and we click on add. Okay. There's two adds here. One is add to the top and the other one is add to the bottom. And that just establishes the priority of a rule. Right now, it doesn't matter which one we do because we're introducing the first rule, right? And so it's both top and bottom. But as you have more rules, you can think about where do I want to put this? Now, after you've added it, you can drag it anywhere you want. Okay, so if you fat fingered it and added it to the top, but you really want it at the bottom, it's not that big a deal. You can just drag it down. Okay. The other thing is when you create the rule, it's not going to be active yet. Okay. That's just in case you make a mistake. So when I go add a new rule, it's going to ask me a bunch of questions. Okay. So the answers I'm going to give is typically I'm going to be passing data through. Now I could also have a rule which explicitly blocks or just ignores a packet that comes in. But most of the time, by default, it's a block. Most of the time, I'm actually doing a permit. Okay. Then you have to indicate what interface that should be pre-populated for you because you're in op2 and you're saying you want to add a rule. So it's going to have that information, right? Then you have to decide on the address family. So is this an IPv4? Is this an IPv6 type of packet? And then what kind of protocol is it? Is it TCP or is it UDP? Because those are different things, right? Uh, then you specify any kind of source IP address. So I could put any, which is what I'm going to do. But you could also be very, very specific. So you could say, I only want this particular server to have access to that interface. Okay. In which case you'd provide its IP address along with a subnet mask. Okay. But we're going to allow any. So anybody on the opt2 network, if they try, this rule is going to allow them to connect to that interface. The destination that we want to permit is going to be 192.168.99.9. So the explicit IP address of the LAN interface. Okay. And then we give a port range, but really it's a start and end range, which is the same port 80. Okay. So when you're just dealing with one port, you still have to provide a range. It's just the same values. Okay. There are circumstances, and you're going to encounter that, where you have to open up more than just a single port. It might be a range of 50 IP addresses, 50 ports. Okay. And it's assumed that um, those are a sequential block, right? Otherwise, it's a little hard to specify them except individually. So. And then you could do any option. So usually you put in a description so that when someone comes into your router firewall and they look at it and they're like, what the hell did he do? You have a little bit of an explanation here of why the rule exists, right? And then you save it. Once you save it, you're going to see it here with a quick summary. If you feel like you made a mistake, you can go and edit it. Okay. I believe no, this one here disables it. And this one here deletes it. I can't remember what this one does. Um, but basically, you want to check this out before you apply your changes. Okay. So far, the rule exists, but it's not being applied. Once you apply the changes, that rule's in place. And if you made a bad decision, um, you might cut yourself off somehow. So, just be a little careful. Make sure that you read things carefully. Okay. Now, once you click on that apply, it's going to indicate that that's done, and then this rule is in effect. Okay. So here, I just have an example of after having set that rule, I've now got um, access to 99.9, but I'm on the OP2 network, which is VMnet 4. No, not 4. VMnet 1, right? So I have an IP address as the connector of 201.11, but I'm now able to get in to the dashboard from there. Okay. So that's some basics of setting up rules. That's going to be handy in some of the classes that you're in right now, maybe 3 of them, right? But it's just kind of a walkthrough for PFSense. Any questions on that before I kind of intro the exercise? Okay. I'll mention None of that rule that we set up, that's not network address translation. Okay. That's just a firewall rule. What you're going to be doing in the exercise is working with network address translation. So I'll just make that a little bigger. I'll just point out this is under ADCS Secure Apps Assessment. Um, so there's the actual assignment, which you won't have access to right away, but there's the NAT Firewalls PowerPoint I did, and here is the exercise. Okay. So it's a little bit further forward. We're going to go back and do a review of certificates in preparation for the quiz, but this particular exercise is here. Whenever you choose to do it, you can actually, like, we're not doing the apps assessment right away, so you got a little bit of time. Okay. But it is going to be kind of important that you familiarize yourself with things. So what we're going to do here is we're actually going to make use of NAT as opposed to what we were doing before, which was just creating permission rules. Okay. So now we're going to say, I actually want you to pass data from the outside world into this internal server, and we're going to see some of the complications that arise from that. Okay. Network address translation does kind of complicate the situation a little bit. So it's going to take a little bit of thinking about it to get used to it and to see the difference between what you're going to be doing in Exchange and what you're going to be doing in this class. Okay, this class is NAT. Exchange is not going to really be using NAT for the most part. Okay, um, unless something goes horribly wrong for some people. So what we're going to do is you're going to set up a web server. So the same web server that you used in the last exercise, if you still have it. Sorry, Ahmad, I think I told you you could delete it, but I hope you didn't. But we want to reuse that one if we can. Okay. Basically, any SSL enabled web server. That's all we're looking for. Okay. Uh, what we want to do is have our router, which you're going to reset the password on, your DC, your sub CA, so that there's a cert that can be checked, and then a web server and a Windows 10 client machine. The Windows 10 client machine should be on the domain, but we're going to stick it out on VMnet 8, so it's going to work from the outside. We want it on the domain so that it's accepted sub-CA and OLCA as certificate authorities, so that when we have our signed cert, it's not going to produce any errors. Okay. But what we're going to see is that DNS names play a role in the functionality of certificates, and networking with NAT can be a little complicated, and it can kind of complicate certificate authentication a little bit. Okay, so it's all going to be about that. Just play around a little bit. In the end, we'll get it working, partly by cheating. Like at the very end, we're going to use a host file entry. But that's not what you're going to do when it comes to the secure apps assignment. But for this one, we're going to kind of cheat a little bit. Okay. First, we'll come up with one solution that works, but it doesn't quite do everything we want, and then we'll cheat to make it work the way exactly that we want it to work. Okay. So this shouldn't take too long, so long as you have your web server up and ready to go. If you haven't done that exercise yet, do that one first. Okay. Questions? All right. You can get out of here. Aiden, you can go throw up in a toilet somewhere. Yeah, no problem. Have a good one. Will do.